So factoring, okay? There's a lot of different ways we can factor. The most common thing that we can look for to begin with is a GCF, a greatest common factor. If I have 2x minus 8, what's the greatest common factor in those two? 2. So if I factor out a 2, what's left from the first term? X. And if I factor out a 2, what's left in the second term? Good. Greatest common factor. Do I need to do a bunch more examples for you? You got that? Okay. The other kind of things that I can do is called the difference of squares. And what did it look like if it was a difference of squares? Well, first of all, it was a binomial. Okay, it was a binomial. It had a subtraction sign because of difference. And each one of these two numbers right here were squares. Do you remember the pattern when we're factoring the difference of squares? If you don't, I will remind you. You get two binomials. It's the square root of the first one at the beginning of each binomial. It's the square root of the second one at the end of each binomial. And the signs are opposite. Do you remember that? We might have the sum of squares. For example, a squared plus 25. Do you remember the pattern when we factor the sum of squares? Okay, we're done. Right? Remember this one was prime? It cannot be factored. The only divisors are itself and 1. Okay, so sum of squares is super easy because you're done. We could have the difference of cubes. What did the difference of cubes look like? Is it binomial? X cubed. Subtract because it's difference. And 27. What's true about each of these two terms? Oh, they're cubes, right? Okay. Do you remember the pattern when we were factoring difference of cubes? If not, can I remind you? No, tell me. Tell me.
It's like the first one.
X minus 3 is the first one because it's the cube root of this and the cube root of this, right? It is. You're right. So this one's a binomial. What's this one? Trinomial. The first term is this one squared. The second term is this times this. And the third term in the trinomial is this one squared. What about the signs for the trinomial? Well, the binomial is always the one that's here. The next one is opposite. The last one, always plus. Guys, my favorite part of this is that some of you are remembering this, and that makes me happy. Yes. Okay. So what's the other thing? What's the other thing we could factor? Difference of squares, sum of squares, difference of cubes, sum of cubes. It's not prime. It's something we can factor. So maybe y cubed plus 125. I'm trying to make these kind of easy. You know that we could have a number in front of the y cubed, right? Just trying to remind you of the pattern. But here, remember what the good part, the good news about the pattern for this one? Well, the way I taught you, it's the same pattern as this one, right? I need a binomial and I need a trinomial. The binomial is the cube root of each one of these with the same sign as our problem. In the trinomial, it's the first term squared, then the first times the second, then the second squared. The pattern is the same as this up here. The first sign is the sign in the problem. The next sign is opposite. The last sign is always plus. Okay? Remember that? And then pretty much, we talked about some other stuff last year in Algebra 2, high school Algebra 2. But the last one we're going to talk about today is just a trinomial. If we have any trinomial, for instance, x squared plus 5x plus 6, do you remember the pattern of what we always did? If this is A, and this is B, and this is C, first we found AC. And that's 6, right? And then we found B, which in this case is 5. What multiplies to be AC and adds to be B? Well, the numbers that multiply to be AC are 1 and 6 and 2 and 3. Which one of these pairs of numbers add to be 5? 2 and 3. So at this point, we recognize that A is 1, and if A is 1, we can do our little shortcut, right? We can go straight to our factors to be x plus 2 and x plus 3. If A is not 1, do you remember what we had to do? Okay, so if we started with x squared plus 5x, we're just pretending for a second that A is not 1. We all know that A is 1. We had to split this middle term into two parts. And these two numbers are what determine the two parts. So we had x squared plus 2x plus 3x plus 6. Do you see how those two equations are equivalent? Then we just looked at the first two terms and figured out what was the greatest common factor that we could get out of the first two terms. What are they both divisible by? An x, right? Well, what's left if I factor out an x? X plus 2. Remember that? Now I just look at the second two terms. What are they both divisible by? A 3. Then I factored out a 3. What's left if I factor out a 3? X plus 2. Now, do these two terms have a common factor? What do they both have? An x plus 2, right? See how this term right here has an x plus 2 and how this term right here has an x plus 2? Factor it out. X plus 2. What's left when I divide this first term by x plus 2? X. What's left when I factor an x plus 2 out of this term? 3. See how I ended up with the same answers? This way is the way we have to do it when A is not 1. This is the way we can do it the little shortcut way if A is 1. Do you remember that? That's pretty much the basis of section 1.4 and 1.5. Okay? So I'm going to leave that as our video for today. Work on some of the homework tonight. If you have any questions, please ask me, and we can definitely do some more talking tomorrow. Okay?